Hello, welcome to today's class. Today's class will be on expansion time loops. So we'll study what expansion time loops is, and actually there are three different ways to create expansion time loops. The first method is to use expansion time variables and expansion time control statements like if and go. The second method is using repeat statement, and the third one is using IRP statement. So these are the things we'll study in today's class. So what happens is it's often necessary to generate many similar statements during the expansion of a macro. Now this can be achieved by writing the similar model statement in the macro multiple number of times. However, instead of repeating the same statement, we may use expansion time loops. To explain this, let us consider this macro where we have used the same statement repeatedly. As you can see in this part of the code, we have repeated the move m statement 3 number of times, and they are almost similar except that we add 1 here and we add 2 here. So we are repeating the same statement multiple number of times. So this is the complete program where we have the macro definition and the macro call and the main program. In the main program we have the macro call, and now if we perform the macro expansion for this macro call, we have to generate all the model statements. Here we have 4 model statements, so these 4 model statements will be generated, and as we generate we have to replace the formal parameter a by the actual parameter b, and this will be our final generated code. I'm not showing the step-by-step generation of the code. By this time you already know how to generate the code for a macro expansion. However, for this macro call, this will be the generated code. And now in place of the macro call, when we put the generated code, this will be your final code after the macro expansion. Now in the previous example we repeated the same model statement multiple times, but instead of writing the same model statement multiple number of times, the same effect can be achieved by writing an expansion time loop which visits a model statement or a set of model statements repeatedly during macro expansion. Now as I said, one way to write the expansion time loops would be by using expansion time variables and expansion time control statements like if and go. This is only the first method. There are 2 other ways to write expansion time loops. We will see that later. So here is an example of a program of a macro definition that use expansion time loops. So here we have the macro definition and we have the main program, and if we look at the macro definition, this is the expansion time loop. So what is happening in the macro definition is we first declare a local expansion time variable m. In the next statement we initialize m to 0, then we have a model statement, and then we have another model statement, and then we increment the value of the expansion time variable by 1, and next we have the if statement. So in the if statement we check whether m is not equal to n or not. So if m is not equal to n, then we will jump to the sequencing symbol more. And where is the sequencing symbol more? It's here. So we go back to more, and this is our loop. So this is the expansion time loop, and we will continue this loop as long as m is not equal to n. Once m becomes equal to n, we will exit the loop and we'll go to the next statement. So this is how we can write expansion time loops using expansion time variable and if statement. Now let us try to perform the macro expansion for the macro call clear b comma 3. Since the actual parameters are b and 3, the mapping will be that x will be mapped to b and n will be mapped to 3. So this is the mapping we have from formal parameter to actual parameter. Next, I write down the statements from the macro here, and I'm doing it just for making it easier for me to explain. And as we copy this line, we should copy the lines just after the macro prototype statement. So this is the macro prototype statement, and the next line is your LCL. So starting at LCL, we copy up to the macro end statement. And I am giving some numbers to each statement. So this is the statement number 1, statement number 2, and up to statement number 7. And unlike in the other class, I will write down the generated code in this slot, and that will be easier for me to explain. So whatever code is generated, I will write it down in this place. And now to start the macro expansion, we need to initialize the macro expansion counter to 1. So the macro expansion counter is initialized to 1, and hence the first statement will be processed. And what the first statement is doing is just declaring a expansion time variable m. So m will be declared. So that will be the end of the processing for this line. So we'll go to the next line. So MEC will change to 2, and in the second line we are initializing m to 0. So as we process statement number 2, m will change to 0, and that's the end of the processing for this statement. So MEC will now change to 3, and since 3 is a model statement, as we process this statement, the model statement will be generated, and that's what we see here. The statement number 3 has been generated, and that's the end of this processing of statement number 3. So MEC will become equal to 4, and when we process statement number 4, we have another model statement, and we will generate this model statement. And as we generate, we should replace the formal parameter x by m, x by b, and we should replace the expansion time variable m by 0. And sequencing symbols will not appear in the expanded code. So for statement number 4, this is what will be generated. X has been replaced by b, m has been replaced by 0, because the current value of m is 0. And the sequencing symbol more do not appear in the expanded code. So that completes the processing of statement number 4. With that, the macro expansion counter will be incremented to 5, and we will now process statement number 5. And statement number 5, it increments the value of the expansion time variable m by 1. So statement number 5 increments the value of the expansion time variable. So your m is 0, it will be incremented to 1, and that completes the processing of statement number 5. So MEC will now change to 6, and in 6 we have this if statement, and here we check whether m is not equal to n or not. So if m is not equal to n, then this will be true. So what is the value of m? The value of m is 1. What is the value of n? N is 3. Hence we can say that m is not equal to n, and hence this will be true. And since this evaluates to true, we will jump to the sequencing symbol more. And where is the sequencing symbol more? It is in statement number 4. So since this evaluated to true, we will go back to more. And this is our expansion time loop. We are going back to statement number 4. And we will keep going to statement number 4 as long as this evaluates to true. So since we need to go back to statement number 4, MEC will change to 4. And we will process this statement one more time. And this time when we process this statement, Again the statement will be generated, but this time x will be replaced by b, but m will be replaced by 1. So statement that will be generated is b plus 1, and that completes the processing of statement number 4. So MEC will now become equal to 5, and statement number 5 will again increment the value of the expansion time variable m, hence m will be incremented to 2, and after that MEC will change to 6. And for statement number 6 we will again evaluate this relational expression where we check whether m is equal to n or not. M is 2, n is 3, so they are still not equal, and hence this will evaluate to true. And since this evaluates to true, we will go back to sequencing symbol more. So we go back to sequencing symbol one more time, hence MEC will change to 4, and we will process statement number 4 one more time. And when we process statement number 4, again the model statement will be generated, x will be replaced by b, but this time m will be replaced by 2, and hence this is the line that will be generated. And that completes processing of statement number 4. MEC will be incremented to 5. We increment m, so m will become equal to 3. That's the end of processing for statement number 5. So MEC will be incremented to 6, and now we check the value of m and n. Excuse me. And this time m is 3 and n is also 3. So so it is not true that m is not equal to n. So this will evaluate to false this time, since m is equal to n. And since it evaluates to false, I will not go back to sequencing symbol more again. Instead we will exit the loop and we will go to the next statement. We'll go to the next statement, which means MEC will change to 7, and 7 happens to be the macro n statement, and processing the macro n statement will complete the expansion for the macro call. And at the end, this is the code that we have has been generated. And now we can place this generated code in place of the macro call. So we can remove the macro definition, we can remove the macro call, and in place of the macro call I can put these 4 statements, and this would be my final code that is generated after macro expansion. So we saw one way to write expansion time loops. The second method of writing expansion time loop is using the repeat statement. The syntax for the repeat statement is REPT followed by expression, and this expression should evaluate to a numerical value. And what is the meaning of this statement is that whatever statement appears between repeat and m statement, so there will be a repeat statement and there will be an m statement, and whatever statements appear between these two statements would be processed for expansion expression number of times. So if this expression is 5, those statements will be processed 5 times. If the value of expression is 3, those statements will be processed 3 times. So how many times the loop will be repeated depend on what value we have for the expression. Let us look at one example. So here we have a macro. We have the macro definition and the main program, and in the macro definition, this is my expansion time loop. The expansion time loop starts at the repeat statement and it ends at the end m statement. And here we have the value 3, which means this expansion time loop will be repeated 3 times. Every time in the loop, this statement DC statement will be generated, and after that the expansion time variable m will be incremented, and we can say that these two lines will be processed 3 number of times because the loop will be repeated 3 times. So let us try to perform the macro expansion for this. To start with, we declare a local expansion time variable m. So when we process this statement, the variable will be declared. It's currently not initialized. Next, for the next statement, we will initialize m to 1. Next, we will execute the expansion time loops, which will be repeated 3 number of times. And in the first iteration, in loop iteration 1, we process this statement. Since this is a model statement, it will be generated in the expanded code, and since the value of m is 1, m has been replaced by 1. Next, we'll go to this statement, set statement, which will increment the value of m by 1, so m will become equal to 2, and that completes iteration number 1. So we'll now repeat iteration number 2. So we'll go back to the DC statement and for the DC statement, for loop iteration 2, again we will generate the model statement. This time m will be replaced by 2, so the statement that we generate is DC2. After that, we will increment the value of m, and the current value of m is 2, so it will change to 3, and that completes the iteration number 2. So now we'll since set is a pre-processed statement that is not generated in the expanded code that we have already discussed in the previous class, we generate only model statements in the expanded code. So after the completion of the second iteration, we will repeat the third iteration, and in the third iteration we again visit the DC statement, and since this is a model statement, I have to generate it again, and this time the value of m is 3, so the statement that will be generated is DC3. After that, we increment the expansion time variable by 1, so it becomes 4, and since we have repeated the loop 3 times, we will exit the loop, and then we will process the macro end statement, and that would be the end of the macro expansion. And what this macro did is define 3 new constants 1, 2 and 3, and now I can put this expanded code in place of the macro call. So I can remove the macro definition, I can remove the macro call, and in place of the macro call I can place the expanded code, and this would be the final code after macro expansion. So you have seen how to create expansion time loops using the REPT statement. Next we will look at the IRP statement. So the syntax for the IRP statement is IRP followed by a formal parameter followed by a list of argument. And now what does the IRP statement do is that the formal parameter will take value from the argument list. So if there are 3 arguments in the list, the formal parameter will first take the value of the first argument, and it will process the statements between the IRP statement and the endem statement. Next, it will take the value of the second argument and again process the statements that are between the IRP statement and the endem statement. And finally, it will take the value of the third argument and again repeat process the statements between the IRP and the endem statement, which means the loop will be repeated as many number of times as there are arguments in the argument list. So if there are 5 arguments in the argument list, the loop will be repeated 5 times. If there are only 3 arguments in the argument list, the loop will be repeated 3 times. Let us look at one example. So here we have the macro definition and the main program, and in the macro definition this is my expansion time loop, and for the IRP statement this is the formal parameter and this is the argument list. And since we have 3 arguments, this loop will be repeated 3 times. The first time in the loop, Z will take the value of M and it will generate the DC statement. In the second iteration, Z will take the value 7 and the loop will be expanded. And then Z will take the value of N, and one more time the loop will be processed. So since there are 3 arguments, the loop will be expanded 3 times. In iteration 1, Z will take the value of M. In the second iteration, Z will take the value 7. And in the third iteration, Z will take the value from N. And to perform the macro expansion, this is our macro call. In the macro call, our actual parameters are 4 and 10, which means M will be mapped to 4 and N will be mapped to 10. So this is the mapping from formal parameter to actual parameter. And now the IRP statement, first time Z is taking the value from M, and since M is 4, Z will be equal to 4. And since Z is 4, the statement that will be generated is DC4. That's the only statement we have in the loop. So we'll go back, and this time in the second iteration Z will take the value 7, and this time when we generate the DC statement, since Z is 7, the statement that will be generated is DC7. And then again we'll go back one more time, and this time Z takes the value of N, and since N is 10, the statement that will be generated is DC10. And then we will exit the loop, and the next statement is the macro end statement, and that will be the end of the macro expansion. So at the end we have this expanded code which we can place for the macro call can be replaced with this expanded code. So we can remove the macro definition, we can remove the macro call, and in place of the macro call I can place the expanded code, and this should be the final code that is generated. So what the macro did is defined 3 new constants, 4, 7 and 10. So this is how the IRP statement works, and with that I'd like to end this class. If you have any questions, please post through Piazza. Okay, bye.